Hi guys, welcome to my channel. In this video, I'm going to explain the solutions for this question. So let's start the video. So what the first question? Write the set of strings. So what are the strings? Strings are nothing but the sequence of symbols. We all know. Zeros and ones which with equal number of each over 0 and 1. Means what? What is the question? First understand the question. So by using the inputs 0 and 1, we have to form some sequence of strings. So this is finite language or infinite language? It is a infinite language. Why? Because we have nothing conditioned. So that we can stop at particular point. So we can form as many strings we want by using 0 and 1 as inputs. Now let's see the solution. So if you see here, this is the solution. So by using the 0, 1 as input, we can form as many strings we want. It is an infinite language. Okay, this is the solution for this question. So if you see another question, write the language which has length over a comma b. So if you consider a and b as inputs, so we have to form the strings with the length 2. The length of that particular string should be 2. In that way, we have to form like A, the length of that string is 2. AB, the length of that string is 2. So similarly, let's see the solution, how it will be. Now you look at here, AA, the length of this string is 2. BB, the length of this particular string is 2. Again AB, BA, the length of these strings are 2. So this is the finite language. Why? Because more than this we cannot form any more string by using A and B as input. So this is the finite language. Next, if you see another question, write the language which starts with A over A comma B. If you consider this A and B are the inputs, we have to write the sequence of strings which starts with A. It should start with A, but it can end with anything. It can be end with A or it can be end with B also. But it should start with A. It should start with A. So now let's see how the solution will look like. Now this is the solution. So it should start with A. It can be A, AB, AA, ABB or anything. It should start with A. It can be any type of length, but it should start with A. It can end with A or it can be end with B also. So this type of sequence of strings is infinite language. Why? Because we cannot stop at particular string. We can form as many we want. So it is also the infinite language. Now let's see the another question. Write the language which starts with 0, 1 and ends with 0, 1 over 0, 1. Means what? So if you look at here, it should start with 0, 1 and it should end with 0, 1. That is the condition. So the inputs are 0 and 1. It should start with 0, 1 and 0, 1. It should start with 0, 1 and end with 0, 1. In between, it can have zeros or ones or anything, but it should start with 0, 1 and ends with 0, 1. That is the condition. How the solution will look like? Let's see. If you look at here, this is the solution. It should start with a 0, 1 and end up with 0, 1. It should start with 0, 1 and end up with 0, 1. In between, it can have any type of string. Okay. So now look at here. It is starting with a 0, 1 and ended up with 0, 1. In between, we have 1, 0, 1, 1. In between, it can have any type of a string, but it should contain starting 0, 1 and end up with 0, 1. That is our condition. In between, it can have any type of string. So in this way, we can form as many strings we want. So this is also infinite language. Now, next question. Write a language over A comma B which has length 3. Simple. So the input is A comma B. With the help of these inputs, we have to form the sequence of strings with length 3. Okay, now let's see the solution. So this is the solution. So A. What is the length of this string? Which is 3. B. What is the length of this string? 3. So similarly, each and every string's length will be 3. So this is finite language. Why? Because the length is 3, means 2 power 3 equals to 8. So we can form 8 strings. So it is we can stop at particular point. So that's why this is the finite language. Okay. Now next question. Write a language over 0, 1 which has length at least 4 means what? At least 4. What is at least 4? Means 4 or more than 4. Okay, it can be 4 or we can write more than 4 also. So the inputs are 0 and 1. You can, I think you know how the solution will look like. Now let's see. Now this is the solution. So the length of the particular string can be 4 or more than 4, but it cannot be the 3. It cannot be the length of that particular string is 3. Why? Because it is at least 4 means 4 or more than 4. So the length should be 4 or more than 4. We can form as many strings we want. Yes or no? So more than 4 means we can form as many strings we want. So this is the solution. Similarly, write a language over 0, 1 which has length at most 5. What is at most? At least and at most are quite opposite. At least 4 means 4 or more than 4. At most 5 means 5 or 5 less than 5. It can be 5 or less than 5, but not more than 5. Okay. Now let's see how the solution will look like. Now, this is the solution. So the length of this string 0, 1 is 2, 0, 0, 1, 1 means the length is 4, here 4, again 2, 5, 4, again 4, 3. So the length of this each and every string is less than 5 only, equal to or less than 5 only. Yes or no? But the one thing you have to remember, which is it is not the infinite language, it is a finite language. Why? Because it is less than 5 means 2 power 5 means we'll get some value. Till that we can stop. Yes or no? More than that we cannot go. It is more than 4 means we can form as many strings we want. But here less than 5 means 2 power 5. Less than 2 power 5 means we can stop at particular point. So it is a finite language, but here this is the infinite language. Okay, I think you got the clarity between this both. Now let's see one more thing. Write a language over 0, 1 which starts with B. This thing you know. Similarly, which you have seen here, the string which starts with A, which starts with B. It should starts with B. Okay, I think you know the solution, no need to show. Yeah. Oh, yeah, here it should be A, B. It's my mistake. Okay, the inputs are A, B. From inputs A, B, you should start the string with the B. Okay, write a language over A, B, which is ending with 2 consecutive B's. Means consecutive B means what? Means it should end up with B, B. Okay, in that way you have to form the sequence of strings. Means it can be any type of string in starting, in the beginning. But it should end with B, B. Okay, now let's see the solution. Yeah, this is the solution. So for each and every string, it should end with 2 B's, consecutive B's. So this is also infinite language. Why? Because we can form as many strings we want with the 2 consequence B's at the end. Similarly, we can form 2 consequence B's at the beginning, at the starting also. Now, write a language over 0, 1 which satisfies the given condition, which is modulus of S mod 3 equals to 0. Means what? So it should satisfy the 3 conditions. Like it should divisible by 3. In that way we have to, for it's not divisible by 3. Like if you see, I'll show you the solution and I'll explain you so that you can get clarity. Yeah, the solution will look like here. In this way, means the length of that particular string should be divisible by 3. Means like the length should be, it can be 3 or 6 or 9 or 12. The length should be in this way. Okay, it should divisible by 3. The length should divisible by 3. Okay, the length of the particular string should be divisible by 3. Okay, if you see here, the length of this string is 3. Here 3. Again, this is 6. So in this way, the length should divisible by 3. Okay, that is the meaning of this question. If you see here, write a language which is divisible by modulus of 4 equals to 0 over 0, 1. So, here in this question, what is the difference between this question and this question? Means here the length of the string should be divisible by 3. But here the number, the string which is there, that should be divisible by 4. Okay, here the length should be divisible by 3. Here the string only should be divisible by 4. Now let's see how the solution will look like. So this is the solution, how the solution came. Now let's see. Now look at here, what I have done here, I have taken the 4. So how the 4 is divisible by 2? So divisible by 0, 0 stem, and we'll get the remainder as 0. So the question is also that only, no, we have to get the remainder as a 0. At which condition we are getting the 0? When it is a 0, means the length should be 0, like the length should be 4, yes or no? So 4 zeros, or we can use this epsilon also. Epsilon is nothing but the empty, so that one also we can use. Similarly, we'll try with 1. So if it is 1, when we'll get 1, 0 stem, and what is the remainder? Again 1. So we are getting the remainder as 1. So we have to not take the consideration of 1. Next, let's take the 2. If you take 2, we'll get the remainder as 2. Again, you have no chance to take the 2. Again, let's take the example of 3. So if you take the 3, we'll get the remainder as 3 only. Now, if you take 4, what will happen? Now, if you take with 4, 4 is divisible with 4 one time. Yes or no? And 4 minus 4 is 0. Yes, we are getting the remainder as 0. So, at which condition? When it is 4. Means how we can represent this number 4 in zeros and ones, in byte values. I think you know how we can represent the 4 with zeros and ones. Okay, I will be explaining you one more time, don't worry. Yeah, in this way we can represent, yes or no? I think you all recollected how to write 4 in the zeros and ones. So if you see this number 0100, so the first digit is nothing but 2 power 0 or 2 power 0, and the second digit is 2 power 1, third digit 2 power 2, and fourth digit will be 2 power 3, 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on. Okay, now we are getting the 4. So how we can represent 4 in 2 power? 2 power 2. So 2 power 2 is nothing but the 2 square is nothing but the 4. Means at the third position. So 2 power 2 is at the third position. At the third position you have to keep a 1, and remaining places can be filled with a 0. So in this way we can represent the zeros and ones. I think you know. Similarly, we can try with the other number. If it is divisible by 0, we have to represent the particular number with zeros and ones. If it is not divisible, leave it. Again, we have to go for another number. So in that way, we have to write this sequence of strings. Okay. Again, with 8 number also, we can get the remainder as 0. So if it is 2, so 4 2's 8. So how to represent the 8? 2 power 3. Means 2 power 3 means at the fourth position we have to keep 1, and remaining places can be filled with 0. So this is the number. So similarly we can form the remaining strings also. So in this way we have to solve this question. I think you got the clarity. Using the same solution, you can solve this question also. Write a language which divisible by modulus of 5 equals to 1. Here, the modulus of 4 is equals to 0. Here, the modulus of 5, we should get the remainder as 1. When it is divisible by 5, and it should divisible by 5. Okay. When it is remainder is 1. Here we are getting zeros. No. Similarly, it should divisible by 5. When it should be, remainder should be 1. The remainder of the particular thing should be 1. That sequence we have to form. Okay. I think if you understand this question, you can solve this question. So I am giving the chance for you only. So try the solution by yourself and send me the solutions to my mail ID or comment below this video. Okay, this is very easy, so you should have the thinking skills, and then it will be more easy for you. And yeah, you have to practice as many questions are there. At that time only you can get to know how this will come. Okay, just practice is more and more important. Okay, try this solution. When remember the remainder should be 1, not the 0. Okay, the remainder should be 1, not the 0. Remember this. So try the solution and send to my mail id. Yeah, that's it for this video. I think you understood the solutions. You have still, if you have still any doubts, please mention in the comment section. I will be definitely solve your doubts. And that's it for this video. Thanks for watching. Let's meet in the next video.